Picture this. You're standing on tarmac so hot it could literally cook an egg. The air shimmers at 54 degrees Celsius. That's 129 Fahrenheit. Your phone shuts down from overheating. This isn't some post-apocalyptic wasteland. This is Kuwait in summer. And right in the middle of this desert inferno, engineers are building something impossible. A $4.3 billion airport terminal designed to handle 25 million passengers a year. Kuwait holds a terrifying record. In 2016, temperatures hit 54 degrees Celsius, the third highest temperature ever recorded on Earth. That's not a typo. We're talking about heat so intense that asphalt melts, car dashboards warp, and human survival becomes a daily engineering challenge. In 2021 alone, Kuwait endured 19 days above 50 degrees Celsius. Think about that. 19 days where stepping outside could literally kill you. Yet in the middle of this hostile environment, Turkish construction giant Limak is building what might be the world's most challenging airport project. This isn't just another airport expansion, it's a complete reimagining of how massive structures can function in extreme heat. The terminal will span 1.2 kilometers across each of its 3 wings. That's roughly 12 football fields of building, all designed to stay cool when the outside world becomes an oven. Here's where it gets fascinating. While most hot climate buildings rely on energy-intensive air conditioning, Kuwait's airport is pioneering something different: thermal mass engineering. The entire structure uses over 1 million cubic meters of concrete, enough to fill 400 Olympic swimming pools. Each of the 804 precast concrete elements weighs between 200 and 360 tons. These massive components aren't just structural, they're climate control systems disguised as architecture. During Kuwait's brutal days, the concrete absorbs heat slowly, staying cooler than the outside air. At night, when temperatures drop, it releases that stored heat gradually, creating a natural temperature buffer. The installation process itself is an engineering marvel. 9 crawler cranes, ranging from 600 to 1,600 tons of lifting capacity, work around the clock. In a country where daytime construction is banned during summer months due to worker safety, the entire project operates on a carefully choreographed night schedule. Foster and Partners, the architects behind Apple's headquarters, designed something unprecedented for the baggage claim area: cooling cascades. Imagine walking through an airport where waterfalls create microclimates within the building. These aren't decorative features, they're sophisticated cooling systems that use evaporation to drop local temperatures by up to 10 degrees Celsius. The water features serve multiple purposes. They increase humidity in the dry desert air, making the space more comfortable for human lungs. They create negative ions that improve air quality. And crucially, they provide psychological relief. The sound and sight of flowing water tricks your brain into feeling cooler. Above your head spans what might be the world's most sophisticated airport roof. It's not just a covering, it's a 300,000 square meter solar collection and heat deflection system. 8,000 skylights are strategically positioned to filter daylight while blocking direct solar radiation. The photovoltaic panels covering the roof generate enough electricity to power a small city. But here's the genius part. They're not just generating power, they're creating shade. The panels block the sun's most intense rays while converting them into electricity, creating a double benefit that's revolutionary in hot climate design. The roof's shape itself is inspired by Kuwait's traditional dhow sailing boats. Those curved, flowing lines aren't just aesthetic, they're aerodynamic. They're designed to channel the hot desert winds up and over the building, creating a natural cooling effect that reduces the load on mechanical systems. Every aspect of this terminal is designed around one core principle: keeping humans alive and comfortable in lethal heat. The central atrium rises 25 meters high. That's an 8-story building, creating a natural chimney effect that draws hot air up and out. The terminal's trefoil design isn't random. Those 3 symmetrical wings create multiple microclimates within the building. Each wing can be independently climate controlled, allowing different areas to adapt to varying passenger loads and external conditions. Walking distances are minimized because every extra step in extreme heat is a survival consideration. The longest walk from the terminal center to any gate is designed to take no more than 8 minutes, crucial when outside temperatures can cause heat stroke in minutes. Beneath the terminal lies a hidden world, the world's most advanced baggage handling system designed for extreme heat. 6 kilometers of conveyor belts operate in climate-controlled tunnels. The system can process 2,930 bags per hour. But here's the critical part. It does so while maintaining temperatures that won't damage electronics or melt plastic luggage components. The underground network includes backup power systems, redundant cooling, and even escape routes for maintenance workers if surface temperatures become too dangerous. It's essentially a subterranean city designed to keep the airport functioning even when the surface world becomes uninhabitable. Building this airport required solving problems that don't exist anywhere else on Earth. Concrete must be poured during the narrow window between midnight and dawn. During summer months, daytime construction is literally impossible. Workers would die from heat exposure. The construction crew operates like a military unit. Night shifts begin at 10 p.m. when temperatures drop to a manageable 40 degrees Celsius. By 6 a.m., as the sun rises, all outdoor work stops. Tools are stored in climate-controlled containers because metal equipment left in the sun becomes too hot to handle. Material storage is its own challenge. Steel reinforcement bars expand and contract so dramatically in the temperature swings that special joints had to be designed to accommodate the movement. Concrete mixing trucks require special insulation to prevent the concrete from setting before it reaches the pour site. Here's the mind-bending irony. This airport, built in one of the world's hottest places, is targeting LEED Gold certification, the highest environmental standard for buildings. It's designed to be the world's first passenger terminal to achieve this level of environmental accreditation. The energy consumption is carefully balanced. While the cooling systems require enormous power, the solar arrays and efficient design features aim to make the building nearly energy neutral. During peak summer months, the airport will consume as much electricity as a small city, but it will also generate a significant portion of that power from its own solar systems. What's happening in Kuwait is bigger than just one airport. As climate change pushes global temperatures higher, the engineering solutions being developed here will become blueprints for survival architecture worldwide. The thermal mass techniques being perfected could revolutionize construction in hot climates from Phoenix to Dubai. The cooling cascade systems could be adapted for hospitals, schools, and residential buildings. The solar integration methods could transform how we think about building integrated renewable energy. Beyond the engineering marvels, this project represents something profound about human determination. In a place where summer temperatures regularly exceed the survivable limits for human beings, thousands of workers are creating something that will serve millions of travelers for decades to come. The construction workforce operates in conditions that would be considered torture in most parts of the world. Yet they're not just surviving, they're creating architectural history. The project requires specialized protective equipment, cooling suits, and medical monitoring that reads like something from a space program. The original timeline called for completion by 2022, but building in extreme heat means delays are inevitable. Equipment failures from thermal stress, limited working hours, and the sheer physical challenge of working in such conditions have pushed completion to 2024 and beyond. Every day of delay costs millions, but rushing in these conditions isn't just expensive, it's deadly. The project managers have had to completely rethink construction scheduling, worker safety protocols, and quality control measures. Traditional construction management doesn't work when your building site regularly becomes unsurvivable. This airport is a statement of national ambition. Kuwait is positioning itself as a major player in global aviation, competing directly with Dubai and Qatar for dominance in Middle Eastern air travel. The $4.3 billion investment represents one of the largest infrastructure projects in Kuwait's history. It's a bet that the country can overcome its geographical challenges and become a major transit hub connecting Asia, Europe, and Africa. The airport's success or failure will have implications far beyond Kuwait's borders. The airport incorporates building information modeling on a scale never before attempted. The entire structure exists as a digital twin, allowing engineers to simulate everything from structural stress to thermal performance before a single concrete block is poured. Smart building systems monitor everything from air quality to structural movement. Sensors throughout the building provide real-time feedback on how the structure responds to extreme temperatures, creating data that will inform future construction projects in hot climates worldwide. As we approach the completion, can this airport handle 25 million passengers annually while maintaining comfort, efficiency, and environmental responsibility in one of the world's most challenging climates? The answer will determine whether Kuwait's $4.3 billion gamble pays off, and whether the engineering solutions developed here will become the blueprint for building in our planet's increasingly extreme future. The stakes couldn't be higher, and the clock is ticking toward the ultimate test of human engineering ingenuity versus nature's most extreme conditions. But here's what makes this story truly remarkable. While the world watches Kuwait's airport take shape, engineers are already planning even more ambitious projects in even more extreme conditions. The lessons learned here aren't just about building airports, they're about humanity's ability to adapt and thrive in environments that should be impossible to inhabit. And that's exactly what makes this one of the most important construction projects happening on Earth right now.